Okay, so get ready to put your math skills to work to solve this interesting little math word problem. Matter of fact, let me go ahead and read the problem. It is the following. A company's profit is given by the following profit function. So this function is P of x is equal to negative x squared plus 10x minus 9, where the value of P of x will be in hundreds of dollars. Okay. So this profit function is P of x is equal to negative x squared plus 10x minus 9, where x is the number of widgets produced per day. And if you don't know what a widget is, it's simply a fictitious product. All right, so let's get back to the rest of this problem. How many widgets must be made to maximize profit? Okay, so that is the question. And some of you might be saying, hey, Mr. YouTube Math Man, this is not a simple little math problem or math word problem. Well, actually, this is kind of a basic first year algebra type of word problem. So if you are in a first year algebra course, well, then you should be able to figure this out. But I'm actually going to solve this problem using algebra, and I'm also going to use calculus as well. But first, I want to give you a full opportunity for you to solve this problem. And if you have the answer, well, put that into the comment section. I'll show you the correct answer in just 1 second. Then, of course, I'm going to walk through exactly how to solve this problem using both algebra and calculus. Okay, but before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need assistance in learning mathematics, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, so again, we have this company's profit is being modeled by this function. Okay, this is a profit function. It effectively models the amount of money the company will make, excuse me, selling these widgets per day. So what we want to do is figure out what is the best amount of widgets to produce per day to maximize profit, right? Because it kind of makes sense. If we produce too many widgets, well, maybe people don't want those extra widgets and then we're going to lose money. But if we don't make enough widgets, well, we're not going to make enough money. So there is an optimal amount. And let's go and take a look at the actual answer. That optimal amount is 5 widgets, and that would correspond to a maximum profit of $1,600. And I'm using this word optimal amount. This is actually a big topic in calculus called optimization, but we don't have to know calculus in order to solve this problem. You're going to see here, I'm going to solve this problem using algebra, but if you know some calculus, if you solve this problem using calculus, you'll obviously understand that using calculus is really, really easy. Well, it's very easy to solve this problem, and it's not that difficult to solve this problem using algebra as well. But of course, we need to understand exactly what's going on. But if you got this right, well, that is fantastic. Matter of fact, I have to give you a nice happy face, an A++, a 200%. Matter of fact, if you were in my algebra class, I would just say take the rest of the year off. I don't know how you got so good in math. Maybe you were watching that guy on YouTube. I don't know. But anyways, great job. And if you're totally lost, don't worry about it. I'll get you understanding of this problem in a jiffy. So let's get into it right now. Okay, so first things first. First, we have a math word problem. Now, this problem again would be something that you would very well see in a first year algebra course, but also this type of problem you could see in a calculus course. Okay, so again, you might be saying, wow, this is so complex, you have to use calculus to solve. Well, no, it's not that complicated. But whether you are talking about calculus, basic math, or algebra, you always want to use the rule of three, and that is read the problem at least 3 times before you start doing anything. I'll tell you, a lot of students really don't understand how important this is because they'll read a problem one time and be like, oh, I know what to do. And they start going down this road and they'll be like, you know what? This was the wrong road. I'm going to go back, reread the problem, and then try to, figure out a better strategy. Oh, this is a much better way to go. And I tell you what, if you're a student, you don't have a lot of time to waste, especially on exams. So the best way to save time is actually to force yourself to be patient, to think about a problem before you start. Okay, so what do we need to do here? Well, what we need to do is understand this part of the problem. Okay, this part of the problem has to deal with functions, and specifically, it's dealing with a quadratic function, and even more specifically, it has to be dealing or it's dealing with the graph of a quadratic function. Okay, so what is the graph? What's the general graph of a quadratic function called? Well, if you know the answer to that question, put that into the comment section. But what we're talking about here is parabolas. Okay, and let's go ahead and kind of visualize what's going on here. So we have this profit function. So x represents the number of widgets we make per day. So if we only make one widget per day, we can determine the profit in hundreds of dollars by plugging in 1 into this function. So to do this problem, you have to have a basic understanding of functions and obviously quadratic functions, and you need to understand how to graph quadratic functions, which is how to graph a parabola. Now, this might seem overwhelming, but again, this is stuff that you learn, or hopefully you've learned in first year algebra. So let's go ahead and kind of get into it right now. Okay, so here is our function, and let's do a fast, quick review of how to graph a parabola, okay? Well, actually, how to graph a quadratic equation, which is a parabola. So let me just draw a quick XY plane here. And let's just focus in on this part of a quadratic equation, which is the x squared part. Okay, now this particular function is in standard form. It's written the highest to lowest power, but let's take a look at another equation here. Let's suppose I have 4x squared minus 5x plus 1, okay? Now again, I want to focus in on the x squared part, all right? This is just a quick kind of highlight on some basic things that you need to know about parabolas or the graphs of quadratic equations. Okay, now here, let's pay attention to the sign of this term, this leading term. This is positive. Okay, it's a 4x squared because 4 is a positive number. And this is in contrast to this problem here. This is negative, right? So the sign here is negative. So we want to look at the signs of the leading terms of these quadratic functions. Now the signs will tell us something. That's a huge clue. When you have a positive leading term, that means we're going to have a positive, happy parabola just like this. And of course, I should have kind of already defined or told you a parabola is a basic U shape like so. That's what a parabola looks like. And again, quadratic functions or quadratic equations that have a positive leading coefficient will have a positive parabola. This parabola is just so happy to be a parabola, so it's like so. Now, if you have a negative sign in front of your x squared term, well, this parabola is negative about being a parabola. It's a little sad. Hey, I don't want to be a parabola, so it has a sad face. That's the kind of the best way to kind of remember this, or at least it's a good way to remember it. Seems to help a lot of students out because this is often confused. So if you have a situation like this negative x squared plus 10x minus 9, when we go to graph it, we're going to have some sort of negative parabola versus a parabola like this. We're going to have some sort of happy parabola like so. Okay, but what is the bigger picture here? Some of you might be saying, hey, Mr. YouTube Math Man, hurry up and make your point. I hear you. Well, here is my point right now. So whether we're dealing with a happy parabola or a sad parabola, you notice here we have an inflection point. Okay, so this one here is the what? Well, this seems to be the minimum point of the parabola, and this point here seems to be the maximum point. But these are critical points in terms of a parabola, and you need to be able to find these points. And this specific point in a parabola is called the vertex. Okay, you got to be able to find the vertex. And again, this is a specific XY point. And you can find the vertex of a parabola using both algebra and calculus. Okay, but what is our situation for this particular problem? Well, we're dealing with a negative parabola. So we're dealing with this kind of situation right here. And if you think about it, our parabola, okay, this function is talking about profit, right? Where this graph is representing the profit. So x would be representing the number of widgets, and Y is the actual dollar amount in hundreds of dollars. So what we're looking for is the maximum profit based upon the number of widgets we make. So let me kind of show you this real quick before we get into the actual problem. That if we start off, because really we're not going to make negative widgets, so we're not over on this side, we're going to be on this side here. So if we start making some amount of widgets like so, if we make no widgets, we're not going to make any money, right? If we make a whole bunch of widgets, well, guess what? We're not going to, maximize our profit. So we got to be able to read this graph. So there is a particular amount of widgets that we can make to maximize the profit. So again, this is the maximum amount. So we want to know this X amount, which represents the number of widgets, to max out the profit. Okay, this process again is called optimization in calculus, but if you understand that what we're dealing with here is a parabola, then all we have to do is simply find the vertex of this parabola. Okay, so now that I kind of set up the problem and we understand what's going on, this is effectively it. You don't even need to graph the parabola. Okay, I kind of went through it. Took some time because this is just very, very important math stuff that you need to understand. But again, you don't even have to have the actual parabola. You just need to understand the concept that this is an upside down parabola. Okay, we're looking for the maximum amount. Okay, so how do we find the vertex of a parabola? Well, let's go to this right here. The easiest way to using algebra is to make sure our quadratic equation is written in standard form. And hopefully you're familiar with standard form, but basically is when we have a quadratic function written in highest to lowest, from highest power to lowest power, ax squared plus bx plus c. This is the form that you need to be in order to use the quadratic formula, okay? And the a, b, and c amounts are the same thing, again, as if you were going to use the quadratic formula. And if you're not familiar with the quadratic formula, well, boy, you really do need some extra help in algebra if you are taking algebra. And I'll give you some suggestions on how you can learn more about this in just one second. But let's talk about how to find the vertex. Okay, so now that we understand the vertex, here is how we find the vertex of our quadratic function. Again, the vertex is a specific xy point. So the x-coordinate of this point is minus b over 2a. Now, what is the b and a? Well, the b and a are the coefficients of our quadratic equation written in standard form. And our y-coordinate is, once we have our x-coordinate, all we're going to do is plug that into the function, and we'll get the y-coordinate. Again, this is something that you should know how to do if you're at this level of math. Okay, so let's go ahead and get into this right now. So here is our profit function, and luckily for us, this thing is already in standard form, ax squared plus bx plus c. So a is going to be the number in front of the x squared, which is -1. So this is our a. B is going to be the number in front of the x, so b is 10. And c is going to be our constant value, which is -9. Okay, so we don't really need the -9, but it's just good practice, especially if we're going to use the quadratic equation to solve this equation. So let's go to figure out what negative b over 2a is. Again, this is going to be our x-coordinate for this problem. So minus b is going to be what? Well, b, again, is 10, so it's going to be -10. Always use parentheses when you're plugging in values for variables over 2a. So this is going to be 2 times a is -1. So we have -10 over 2 times -1, -2. Negative divided by negative is a positive, so that is 5. Okay, so what does that mean? Well, x is 5. Well, let's go ahead and now figure out, or the x-coordinate of the vertex is 5. Let's go ahead and get the y now. And the y, this seems to be very confusing for a lot of students, but it's actually very easy to figure it out. Once you have the x value, all we're going to do is plug that value into the function. So we're going to find f of 5, which is f of negative b over 2a. So we're just going to plug 5 into the function. Here's our function. So let's evaluate it for 5. So p of 5 is going to be equal to negative, we're going to put parentheses, 5 squared plus 10 times 5 minus 9. And of course, when we do all the number crunching here, we're going to get -25 plus 50 minus 9 is 16. Now remember, this is our profit. for 5 widgets in hundreds of dollars. So this is $1,600, right? So we'll make $1,600 in profit if we make 5 widgets. All right, well, what did we just do? Well, we just figured out the answer, okay? So the vertex here, which is the maximum amount, this specific XY point, is what? Well, the X represents the number of widgets and the Y represents the profit. And the maximum, okay, profit is based upon, or is going to happen at this X value. So when we make 5 widgets, we get 16, but again, that's $1,600. So there is the answer. So the correct answer, or the maximum amount of profit for this particular company in terms of number of widgets to make per day would be 5. Okay, so hopefully you understand this, and for those of you that are algebra students, this is something that you need to be able to do, or these type of problems. But let's go ahead and talk about how we can use calculus to solve this problem. Before I do that, though, I need you to quickly hit that subscribe button to show your support for this channel. I put a lot of efforts, not a lot of effort into making these YouTube videos. And I really take my time teaching these concepts because so many students are like this, I don't like math. I'm totally, lost. Well, you know what? It's been my experience that most people struggle in math because they try to rush the process. I'm telling you right now, you can just see by how much explanation I have to give in this particular problem. If I can rush through it, I can show you how to do this problem in like 3 minutes. But most people would be like this, be like, hey, I still didn't really understand what's going on. Or maybe you kind of get it, but if you had to be, all on your own to figure out a problem that was similar to this, you might very well be lost. So the only way to really learn math is to be willing to put in the work. Okay, you're not bad in math. There's no such thing as a bad math student, in my opinion, and I've been doing this for a long, long time. What you have to do is be willing to put in the work because there is a lot of information to know. And most importantly, you need to find a teacher that will teach you in a way that you like and understand with very, very comprehensive math instruction. And that's what I try to do. So if you don't have a teacher, well, I'd like to be your teacher. And it's almost like when you hit that subscribe button that you sign up to be a new student of mine. But I definitely need your support. And if you're going to do that, hit that notification bell as well so you can get my latest videos. Okay, so let's talk about how we can use calculus to solve this problem. I'm going to quickly go through this because this can be a whole nother kind of a huge topic. This is a matter of fact, what I'm going to be talking about here is a huge part of calculus, and it's called finding the derivative. Okay, differential calculus. This is a big, big math. This is one of the biggest reasons why we use calculus. But let me go ahead and show you what I'm talking about. Okay, so we still have the same situation. Here's our company's profit function. We know it is a parabola. Okay, so everything, in terms of that we already talked about is staying the same. Okay, I'll get to the calculus part here in a second. But the objective is I still want to find this maximum point. Okay, well, how do we find this maximum point with algebra? Well, we went through all this minus b over 2a business, and then we found f of minus b over 2a. We did all this algebra stuff, which is perfectly fine to find the maximum amount. But there's another way we can find the vertex, okay? We're still looking for this maximum amount, but there's another way we can do it, and that is using calculus. So how are we going to use calculus? Well, we're going to use something called the derivative, okay? The derivative, and let's go ahead and first calculate the derivative, and I'll just kind of tell you what the derivative stands for. Okay, so let's take our function, p of x is equal to minus x squared plus 10x minus 9. Okay, so we're going to calculate something called the first derivative. I know this seems kind of scary. It's like, oh my goodness, Mr. YouTube Math Man, you're doing calculus. Well, look, finding the first derivative is super easy. Okay, and of course you might be saying, I don't even know what you're doing. I don't even know what it is. Well, I'll tell you in just 1 second. Okay, so minus x squared plus 10x minus 9. So we're going to take this little 2 right here. We're going to multiply by this negative 1. That's really a negative or negative 1. So 2 times negative 1 is what? Negative 2. And then we're going to take this x and we're going to decrease by 1. All right, so you see what I'm doing there? 2 times negative 1 is negative 2x. And then I'm going to take this 2 and I'm going to decrease my power by 1, specifically 1. So I have x to the first. Okay. So I'm actually calculating the first derivative from this function. And now we're going to use the same thing over here. So I have 10x to the first. So 1 times 10 is 10. And then I'm going to decrease my power here, x to the first by 1. So it's x to the 0. Anything to the 0 power is 1. And I am done. When we take the derivative of a constant, it's just going to be 0. So this effectively is the first derivative of this function. Now, what does this mean? Well, this is super powerful. This is the slope, okay? In other words, I can find the slope anywhere along this parabola. Now, what is the slope? The slope is kind of like, the slope of this line, okay? So you can see this parabola, or not this line, the slope of this parabola. So the slope is the rise over the run. So you can see this parabola has various slopes depending on where you're at in the parabola. Now, if we look here, okay, right over here, to get to the very top of the hill, this maximum, the slope is what? Well, the slope is going to be perfectly 0, okay? That is the slope of where the maximum is located. Okay, see that right there? It's a line, and then as we start going on this side of the parabola, it starts to kind of go downhill like so. Okay, so what I want to know is, where is the slope equal to 0 on this parabola? Okay, well, it's equal to 0 on this parabola when it's at the very top, which is the maximum. Okay, so if I know that's where the slope is equal to 0, and I have an equation or formula for the slope, well, all I have to do is set this equation, which is the slope, equal to 0, and it will tell me the x value where the slope will be equal to 0, which of course will be the maximum. Okay, all right, so let's go ahead and do that. So negative 2x plus 10, I'm going to set that equal to 0 and solve for x. You can see I'll move the 10 over to the other side. So I have negative 2x is equal to negative 10, and I'm going to divide both sides of the equation by negative 2. X is equal to 5. Boy, doesn't that look familiar? Let's go all the way back over here and recall that x was 5. Okay, that was our first value that we calculated here with minus b over 2a. But I had to go through all that minus b over 2a business to figure that out. But when I was using calculus, all I had to do was to calculate the first derivative and be like, oh, I know where the slope is equal to 0, where it's at the vertex or the maximum. So I just got my little formula for the slope, set that equal to 0, solve for x, and there you go. Now, if I wanted the y value, I would do the same thing. I would plug that information back into the function, and then, of course, I would have the y component to this xy point, which is called the vertex. All right, so actually I covered a lot of ground here, and now let me give you some suggestions for those of you that are at this algebra level of math. Okay, now I don't teach a full calculus course. Although a lot of people have asked, hey, Mr. YouTube Math Man, can you make a calculus course? Well, no, at this time I don't. I have a full pre-calculus course, which is a very demanding, comprehensive course. So if you're going into calculus, you're going to have to get to that course. You'll find links to all these courses in the description. But the type of problem that we're doing here is like an Algebra 1, College Algebra, Algebra 2 type of problem. And if you need help with all this stuff, well, just check out those various courses. I fully teach quadratic functions, parabolas, and of course I go over a lot of different type of word problems like this. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.